Alright, there's going to be absolute value equations and inequalities on this thing. The first thing that you want to do is isolate the inequality if it's not already done for you, like it is here and here. So for this first one, you have to work your way to it. So subtract 8 first, and then from both sides, and then divide both sides by minus 3. So 4 minus 4 minus 8 is minus 12, and divided by minus 3 is positive 4. So this gives you absolute x minus 5 is equal to positive 4. Now, when you see absolute value equals some positive number, you have to set the argument equal to this number and its opposite. So we're going to want x minus 5 should equal 4, or x minus 5 should equal minus 4. And so you just take both of those, add 5 to both sides, and in this case you'll get x equals 9, and in this case x equals negative 1. You can substitute those back in and show that they do indeed work. For number 2, we got here, there's nothing else to really solve for. We're going to treat this one the same way that we treated this other one by the time we got to this point here. So all that you do is drop the absolute value bars and set the inside expression equal to 12 and its opposite, and then just solve it like a regular equation. So we want 3 minus 5x divided by 4 to equal 12. Or we also want 3 minus 5x divided by 4 to equal minus 12. Either of those will make the absolute value statement true. So multiply both sides by 4, and that'll give you 48. So we'll have 3 minus 5x is 48, and 3 minus 5x is minus 48. And then what? You got to take away 3 and then divide by minus 5. So 48 minus 3 is 45. Right, divided by minus 5 is minus 9. So that one's minus 9. And this one, minus 48 minus 3, 49, 50, 51. So you get minus 5x equals minus 51, and so you divide both sides by minus 5, and you get x equals 51 over 5. If you can see that, yeah. I know that's a little crammed in there, but okay. This one here, if you have absolute value is less than some number, what you want to do is you want to sandwich this inside expression between 4 and its opposite. So if it's a less than, it's pretty easy. You just want to make sure that 5x minus 7, drop the bars, is between 4 and minus 4. And then you just solve it just like any other thing. Add 7 to all 3 pieces. So that'll be 3 is less than 5x is less than 11. And then just divide all 3 pieces by 5, and you'll get x is between 11/5 and 3/5. This next one up here, all we have to do is divide out the 2 first. Don't forget to flip the sign. When you divide both sides by minus 2, you'll get absolute 3 minus 2x is greater than 5. Right? Yeah. And so when you have an expression that's greater than, you want to make sure that the inside expression is either greater than 5 or less than its opposite. So drop the absolute value bars and yeah, there you go. Sorry about that. Drop the absolute value bars and rewrite it. So that means that we want 3 minus 2x to be greater than 5. Or we want 3 minus 2x to be less than minus 5, or equal to, or equal to, or equal to. You see all that? So then I bring this over to the other side so I don't have to divide by any negatives and flip any signs. If I trade these places here, I'll subtract 5 from both sides, and I'll get minus 2 is greater than or equal to 2x. So then I can just divide by positive 2. And get x is less than -1 is less than or is greater than or equal to x. And I'll do the same thing in this case, add 5 to both sides, so I'll get 8 is less than or equal to 2x, and then divide by 2, and you get x is greater than 4. So again, you'll get something that's greater than 4, so that's something on this side of 0 on the number line, and something that's less than -1, so that's something on to this side of 0. So that is the solutions for that. And for this one on here, negative absolute, something is less than or equal to 8. So multiply both sides by -1, and that'll give you absolute x plus 3 is greater than or equal to -8. And you can stop right here because you know that whatever comes out of an absolute value expression has to be a positive number no matter what goes into it. And so what we have here is absolute something is greater than or equal to a negative number. So you can just jump straight to it and say all real numbers are going to be the solution. Because anything that you plug in is going to make this thing a true statement. And we didn't talk about this one in class, but I want you to write it. Write an absolute value inequality that fits the description of that describes any real numbers that are within 5 units of 10. Not going to worry too much about this, but I am going to do it because it's on the sheet. One way to interpret absolute value, if you have, let me just do this up in here. If you have the absolute value of, say, x minus 10, this is interpreted as the distance between x and 10. Whenever you have subtraction inside of an inequality, you could interpret that as the distance that x is from 10 on a number line. So if you know that, then all that you have to do is say anything that are within 5 units of 10. That means that the distance between x and 10 has to be less than 5. And if you solve this inequality, what you'll get is you'll say x minus 10 is sandwiched between 5 and its opposite. And then when you add 10 to all 3 sides, you'll get 5 is less than x is less than 15, which indeed does this does fit the description, right? Any real number. This is clearly referring to numbers between 5 and 15 because they are both within 5 units of 10. So that's how you set it up. This is how you get the answer, but I'm not too worried about it. Now, for this one, since you all have this sheet at home, I'm just going to kind of show these. All right, I give you the graph, and I wrote these in myself, so I don't have to keep referring to x's and y's to compute like f of 4 and f of -1 and all that stuff. But the questions are here for anybody who doesn't have them. All right, I want all of these, and they all refer to the graph, which I'm pretty much going to have shown for the rest of this part of the video. And I'll just answer the questions based straight off of this graph. So I think the whole thing is in the camera there. The first thing, all right, look, I filled out this column here. These are the inputs and these are the outputs. This is where f sends all of these numbers. These are the ordered pairs that show up on this graph. So if it asks you something like what is f of 2 or what is f of 3 or f of 1, all that you have to do is go to this number, go to whatever number it is. Like the first one is f of 2. That's asking where does f send to. I could do it in one of two ways. I could either go on the graph and say, okay, count over 1, 2. Where does it get sent to? -1. So -1 is the answer to that first one. Or because I filled out this table with all these ordered pairs, I could just say f of -2 is -1. So the answer to f of 2 is -1. The answer to f of 3 is you go in x, f sends 3 to -2, which corresponds with 1, 2, 3 minus 2. The second one says solve the equation f of x equals 2. That means that you go into this column, find 2's, and find any numbers that get mapped onto it. So the one way of doing it is say, there's only 1, 2 in here, and that's here. So the solution to the equation f of x equals 2 must be 3. And the other way that you could see that is by looking on the horizontal lines in the graph. Find +2, which is up here, And the numbers that get mapped onto this horizontal line are 0 and -4. Oh, whoops, I'm sorry, 0 and -3. And I actually missed that when I went in the chart, right? It says f of x equals 2. There are two numbers that give me 2. So they're -3 and 0. Similarly, for that second one, it says f of x equals 3. Solve f of x equals 3. You go in here, you try to find any 3's, and there's only one 3. So it appears that f of -1 is 3, so -1 is the answer. Similarly, you can look in the chart, look up here. 3 is up here on the y-axis, on the f of x axis, and there's only one value of x that maps onto it, and again, it's the -1. Now, these next ones, it says f of x minus 3 equals 2. Let me get a piece of scrap paper here because I want to show this to you. Alright. It says f of x minus 3 equals 2. In order to answer this, you need to know what's going to give you 2 as an output anyway. Alright, like f of blank equals 2. This is the way I want you to think about it. So you go back to your chart and you look and think which numbers give me 2 as an output. Well, we already solved that 2 problems ago. We said that it was -3 and 0. So it appears that whenever what's inside here, if this thing is -3, you're going to get -2 out. Or if this thing is 0, you're going to wait. It was 2, yeah. You're going to get 2 out. So what you want to do here is you want this expression, you want x minus 3 to be equal to either -3 or 0. You want to find the value of x that makes this expression equal to one of these two numbers. And the way that you do that is you just set it up. You want x minus 3 to either be equal to -3, or you want x minus 3 to be equal to 0. Because if x minus 3 is either of these numbers, then the output is going to be the number that you want. So all that you have to do once you set that up is to just solve the equation that you came up with, right? X equals 0 or x equals 3. Notice that and these are the answers, 0 and 3. Now notice that these two answers are 3 more than the original 2 answers that gave you 2 out, right? F of x equals 2. The answers were -3 and 0. These two numbers gave us 2 out. So if you're subtracting 3 from what you're putting into it, then the answers for this one are going to be x has to be 3 more than what it used to have to be to give you the same outputs, to give you that 2 out. Because you're subtracting 3 first, 0 is going to work and +3 is going to work. There's a similar concept happening with the next one. It says let me just do this. It says f of x squared equals 1. So go on the chart, or the graph, and you figure which numbers are going to get, which number or numbers are going to give you 1 as an output. If you look in the chart, it's easy. There's only one 1 here, and it appears that 1 is the input that maps onto it. So 1 is one answer, and you can look at it from the graph too. It appears that the graph only crosses this line 1 at one point, and that's at this x value. So 1 is indeed the answer. So what we know is that f of 1 gives us 1. So what we want to do is, since we're taking f of x squared, we want x squared to give us 1 out, right? If x is a number such that when we square it we're going to get 1, then f of that number is going to give us the one that we want. So we just set x squared equal to 1. And of course the solutions will be x equals plus or minus 1. So these are the answers for that. And you can always check these out too, right? If it says, because look, if it says, think about it, f of x squared equals 1. We just said that if x is plus or minus 1, this is going to solve this equation. This is going to make it true. So when we make either x positive or -1 in here, in both cases, what the result will be a 1 inside the f, and we know that is going to give us 1, and so that's what makes that that way. The next one says solve f of x is less than or equal to 0. Again, two ways of doing it. You can either look in the table here and find the negative values, find the values of f of x that are less than or equal to 0 here, and it looks like we got some down here. To get the exact numbers, though, we look at the graph, and these numbers down here, this section of the chart corresponds to this section over here. So the values of x that make f of x less than or equal to 0, it appears that they're going to be numbers like 2, 3, 4, and 5. If you go over, but if you look at the chart exactly, the numbers that are going to put f of x underneath the x-axis, it looks like it's going to be between 1.5 and 5 inclusive. So it's everything between 1.5 and 5. Of course, since we didn't plot 1.5 on the in the chart. This is kind of like a failing of the chart, right? It's like a shortcoming. The graph tells us what the actual answers are, every single one of them, if you know how to read it. So we're looking for wherever, if we want to solve f of x is less than or equal to 0, we're looking for these points down here below the axis, and the x values that give them are everything between 1.5 and 5. The final one is f of x is between -1 and 1, and you would do it in the same fashion. Look for values of f of x, the outputs, that are between -1 and 1. And it looks like there's one here, right? That's 0, so that's between -1 and 1, and so is this and this. So we're definitely going to get some answers just from looking at this chart. So it appears that we're going to get something around like 1 and 2 and 5. Look at the chart to get the exact answers. Now, what's going on with 1 and 2? If you're looking at this, the way that you have to interpret this is not to look at, all right, if you're looking at it from a chart, you're looking for where are the outputs inside the range that you want, which is between -1 and 1. If you're looking at it on the graph, you have to locate -1 and 1, which is everything inside this region here, right? This is 1, and this is -1 on the y-axis. So if we cover up the graph, we cover up everything but, right, between -1 and 1, we'll be looking at the answers. Let me get in there. There you go. These are the values of x that are going to make it. These are the points we're looking for. All right. So f of x is between -1 and 1 whenever the graph is shown in this range here. So we do have some hits. So there's one here and there's one here. Now, but the question is asking for the x values that correspond to these y values. So what you have to do is take the x values of the points that you're looking at, and it appears to be everything between 1 and 2. So all these x values give you y's that are in the appropriate range. And if you count, this lowest value here is 4 2/3. If you go up 4 2/3 on the x-axis, and so it's everything between 1 and 2, and or I should say, or everything between 4 2/3 and 5. And that's how you do that. So it's a little complicated, but that's the way it goes. Coming up on the end of this here, give the domain of f. The domain is just all this is the set of all the inputs. So it's one way to interpret it is the numbers that are listed in this chart here, but there are more numbers in here though, right? There are more numbers in between. The chart is incomplete. So it would be everything between -3 and 5. You could see that from the table, but you could see it from looking at the graph too, because only x values between -3 and 5 get mapped onto some number, right? This number out here, -4, is not in the domain because -4 doesn't get sent anywhere. It doesn't correspond with any point on the graph. So the smallest or the least value that counts is -3, and the most, as far as it goes, is 5. So the domain is everything between -3 and 5. And for the range is the set of the outputs. So you would just look at this column, and you would count or try to figure out a way to write down every one of these numbers. But once again, this is an incomplete table. Only the graph shows the entirety of the y values that are listed here. So not only is it numbers like 3 and 2 and 1 and 0, it's all the interim numbers, right? All the fractions between 2 and 3, and all the fractions between 1 and 2. And if you take all of them, the totality of it all is, the range is between -3, alright, so like the y values that get mapped onto is everything between -3 all the way up to +3, so between -3 and 3. Lastly, give the values of x where f is increasing. Increasing means where the graph is going up and to the right, like this. So it's increasing from -3 to -2 because that's where the graph is going up, and it's also increasing from 4 to 5 because that's where it's going up there. And that's it for this question. At the bottom, it says to just sketch g of x equals x. So this tells you what to do. You have to generate your own chart here by just plugging in inputs and getting outputs and then just plotting them. So g of x equals x. So if x so let me get this out in red here. So if x is 1, g of x is 1. So 1 goes to 1. If x is 2, g of x is 2. 2 goes to 2. 3 is going to go to 3. 4 is going to go to 4. -1 is going to go to -1. -2 goes to -2, and so on and so on. And especially so on for all the numbers in between. This line represents where y and x are the same. Right? G of x equals y equals x. They're the same value. So that's the graph of g of x equals just x. This thing here, g of x equals x squared. This says to take the inputs and square them. So if I plug in 0, I get out 0 because 0 squared is 0. If I plug in 1, I get out 1 because 1 squared is 1. I plug in 2, I get out 4 because 2 squared is 4. -1 squares to 1. -2 squares to 4. And you find that if you square all these interim values here, like say say 1/2 is going to square to 1/4, so I'm going to go up, but not quite. 1/2 is right in the middle of this square here, but 1/2 when squared gives you 1/4, so I got to go down to 1/4. And -1/2 does the same thing, right? It's working out like that. So if you were to plot every one of these, if we could, you would find that the graph would shape itself like this curvy shape here. And that's why we say that x squared looks like that. Similarly for absolute value, whatever number goes in, you just make it positive or you compute its distance from 0, and that's the output. So absolute 1 is 1, and absolute 2 is 2, and absolute 3 is 3, and absolute 4 is 4. Alright? And absolute -1 is also 1. Absolute -2, 2. Absolute -3, 3. Absolute -4, 4. So this graph makes the V shape with which we are all familiar. Notice that it's never underneath the x-axis because we know absolute value by definition is never negative. But this is the reason why it's shaped this way. You could also see this graph as the absolute value transformation of just this, right? If you take g of x equals, say, absolute x, what's that going to do? It's going to take all these, or rather, if I say that this is g of x, and I say graph absolute g of x, what's it going to do? It's going to take the values of g of x that are negative and flip them up and make them positive. If g of x is already positive, it isn't going to do anything. So these points stay the same. Right? All these points stay. All of these y values, all these g of x values change their sign and they flip up. Hence another interpretation of the V shape. For these ones on the back, I'm going to go through these kind of quickly. If you have this, it's going to be a good idea to write these numbers down in a chart just like I have them here, because I'm going to refer to these over and over again whenever I have to do G. All right, wherever a G comes up in any of these problems, I'm going to be referring back to this chart to tell me where G sends the inputs. Now look, this really isn't so bad. It's just you have to take the operations that are given to you in sequence, and you just have to get the order right. If you know how to do this problem here, if I can give you this chart, and if I ask you what is G of 1, what is G of 2, what is G of 3, and if you can properly fill this thing out, then you should have no problem doing the reverse of this. It's just a matter of taking your time and plotting everything with enough care. So for example, this first one here, when I plug in a value of x, you got to get the order of operations right. First you subtract 1, then you do G. By that I mean refer to this chart to see what the output is, and then to those answers we're going to add 2 and finally plot the result of that. So that's the way all this goes. So I'm going to start I'll go with 0, say. Alright, plug in 0. 0 minus 1 is minus 1. G of minus 1, again, you should have that chart handy because I'm going to be referring to it quickly. G of minus 1 is 2, and 2 plus 2 is 4. So 0 got sent to 4. And then I'll plug in 1. 1 minus 1 is 0. G of 0 is 1. 1 plus 2 is 3. Plot that. And then I'll plug in 2. 2 minus 1 is 1. G of 1 is 0. 0 plus 2 is 2. And then I'll try 3. 3 minus 1 is 2. G of 2 is negative 1. Negative 1 plus 2 is positive 1. I'll do 4. G of 4, 4 minus 1 is 3. G of 3 is minus 2. Minus 2 plus 2 is 0. Do minus 1. Minus 1 minus 1 is minus 2. G of minus 2 is 0. 0 plus 2 is 2. And if you look at this, what it's doing is it's plotting the original graph, only it's shifted around like so. Right? X has to be 1 more than it used to have to be, so that means that it's going to shift the entire graph to the right 1 unit, and the former outputs of G are going to be 2 more than they were, so that's going to be a shift up of 2. As I'm reading these, you should be referring to the chart that you already should have written down to make sure that that you are going along with it as I am. This one is a little bit easier because it's just a two-stepper. You just have to add 2 and then do G. So I'll plug in 0. 0 plus 2 is 2. Look at the chart. G of 2 is minus 1. So I plot that. I'll plug in 1. 1 plus 2 is 3. G of 3 is minus 2. Plug that in. Plug in 2. 2 plus 2 is 4. G of 4 is minus 1. Plug in 3. 3 plus 2 is 5. There is no G of 5, right? G stops at 4. So I can't plot anything over here because there's nothing over here to plot. So I'll go with minus 1. Minus 1 plus 2 is 1. And G of 1 is 0. Come back here. Minus 2 plus 2 is 0. G of 0 is 1. And if I do this enough times, I'm plotting out the same graph, only it's shifted over 2 units from where it was. Right? Because 2 units to the left, because I'm adding 2 first. G has to be 2 more than what it used to have to be to give me the same outputs. Let's do this one. Start it up again. Plug in 0. 2 times 0 is 0, and G of 0 is 1. Plug in 1. 2 times 1 is 2, and G of 2 is negative 1. Plug in 2. 2 times 2 is 4, G of 4 is negative 1. Now this is looking weird so far. Plug in minus 1. Minus 1 times 2 is minus 2. And g of minus 2 is 0. Plug in minus 2. 2 times minus 2 is minus 4. G of minus 4 is minus 1. Now this one is tough because you have to double all the inputs first. If I start doing numbers like, say, 1/2, I'll plug in a half, just see what happens. I say x is 1/2. 2 times 1/2 is 1, and g of 1 is 0. So I plot this one. 1.5. 2 times 1.5 is 3, and g of 3 is minus 2. So this is how I can get like a better look and shape in here. I'll plug in minus 1/2. Minus 1/2 times 2 is minus 1, and g of minus 1 is 2. And the graph is going to look like this. Everything is crushed in by a factor of 2 because because x has to be half of what it was, half of what it used to have to be to give you the same outputs. For example, in the upper graph here, if you can see that, right? Okay, 4 used to give us minus 1, but now 2 is going to give us minus 1 because we are doubling it first. And 2 used to give us minus 1, but now 1 is going to give us minus 1 because we are doubling it first. And that's the effect that it's going to have. Now, this thing here isn't a whole lot different from anything else. You just plug in a value of x to g and subtract that same number from the result. So if I plug in 0, g of 0 is 1. So it's going to be like this. Now here, it's going to be g of 0 minus 0. When I plug in 1, it's going to be g of 1 minus 1. When I plug in 2, it'll be g of 2 minus 2, and so on and so on. So if I'll start out with 0, g of 0 is 1, and 1 minus 0 is 1. So I'll start off with 1 here. Let me see here. Let me come up so I can write some of these down here. I don't know. Now let's go to 1. So it's going to be g of 1 minus 1. So g of 1 is 0, minus 1 is minus 1. When I go to 2 here, that's going to be g of 2 minus 2. So g of 2 is minus 1. Minus 2 is minus 3. Let's go with 3. It's going to be g of 3 minus 3. G of 3 is minus 2. Minus 3 is minus 5, so that's way down here. Alright, let's go with minus 1. It's going to be g of minus 1 minus minus 1, or rather g of minus 1 plus 1. So g of minus 1 is 2, minus minus 1 is 3. Try it over here, and plug in the minus 2. It's going to be g of minus 2 plus 2. So g of minus 2 is 0 plus 2, brings me here. Same thing, it's going to be g of minus 3 plus 3. So g of minus 3 is minus 1/2, plus 3 is 2.5. So it's going to look something like this. Alright, something to that effect. Alright, this thing here. Alright, we got 3 operations. First do g, then take away 3 from that, and then finally absolute the answer that you get from that. So we'll start just like I start anything else. I'll start at minus 4. G of minus 4 is minus 1. Minus 3 is minus 4. Absolute, positive 4. Plug in minus 3. So g of minus 3 is minus 1/2. Minus 3 is minus 3.5. Absolute is positive 3.5. Minus 2. G of minus 2 is 0. 0 minus 3 is minus 3. Absolute, positive 3. Minus 1. G of minus 1 is 2. 2 minus 3 is minus 1. Absolute, 1 again. Put in 0. G of 0 is 1. 1 minus 3 is minus 2. Absolute, 2. Plug in 1. 1 minus 3. And that, no, I'm sorry. Plug in 1. G of 1 is 0. 0 minus 3 is minus 3. Absolute, 3 again. And what you're doing is, it's going to look like this. When I plug in 2, G of 2 is negative 1, minus 3 is minus 4, absolute, puts it up here again. Alright, let's see if I try this one, what I get? 3. G of 3 is minus 2, minus 2 minus 3 is minus 5, absolute is off of the chart. Plug in 4, G of 4 is minus 1. Minus 1 minus 3 is minus 4. Absolute is 4. So this thing would look like this. Alright, so what this is doing is it takes G, moves it 3 down, so it's going to take this original graph, move it 3 units down, and then flip that up. So I could have done that same thing with just like saying, alright, G of X, minus 1, minus 2, minus 3, and then absoluting it, sticking it back here. Like this one would be G is here, minus 1, minus 2, minus 3, absolute sends it up here. G of this, minus 1, minus 2, minus 3, absolute sends it back here. That's just another way of doing it. Okay, I give you this and I ask you to identify this graph here. If I just sketch it lightly above, so I have something to refer to, so it goes up like this. Like so. And let me do the same thing here. Alright, so if you get good at this, then you can identify what's going on here, what's got to be done. To transform this, let me see if that's clear. To transform this pencil graph into the bold graph, everything has to flip around horizontally and then get moved down by 1. If you take this graph, switch all the x values, and then subtract 1 from it, you'll get the resulting graph. So if you did enough of these, you should know that the answer is going to be f of minus x will flip everything about the y-axis, and then when you take 1 away from that, it'll bump that whole thing down, and we'll move it right into position. And this last one over here, how to get from the pencil to the bold graph here. It appears that everything is brought in by a factor of 2, right? So this used to be at 1, now it's at a half, right? Like this, and it's flipped, right? So this is out here, but it gets drawn in by a factor of 2, right? To 1.5. So it's squished in and then flipped around. This one would be minus f of 2x. Right, the minus does the vertical flip, the 2x does the crushing in, and the last two I have here, let me see, if I'll just zoom out a little bit so we can see all that. The 4 questions I asked for f of g of 1. So f of g of 1. That just means, here, when you see this, when you see f of g of 1, what you should think is, do g of 1, you know how to do that. You can accomplish that. It basically means read this answer off of the graph of g. And whatever you get for that, you're going to plug in then to f. And then you're going to evaluate that. And that's what the answer is going to be. And that's what it's going to be in all of these cases. So for example, it says f of g of 1. So I do g of 1 is minus 1. And f of that number is positive 1. So f of g of 1 is positive 1. The next one is g of f of 2. So g of f of 2. So f of 2 is on the inside, so we go to the f graph. So f of 2 is 2. And g of that number is minus 2. So f of g of 2 is minus 2. Next one is g of 3. So I do g twice. So g of 3 is minus 1, and then again g of that is plus 1. So g of 3 is positive 1. And lastly, we have f of 2. So you go on the f graph, you do f of 2, which is 2, and then you do f of that, which is just 2 again. And now that I got all the answers written down here, I will circle them all and just show them in case anybody wants to see the final answers for all of these. And here they are. Let's see, zoom in. What do we got here? 1, 9 and minus 1. 2 is 9. And this. 3 was these. Get out of here. 4 was these two. 5 was all real numbers. This is the process for 6. The graph answers these. The graphs. It's actually just this. Alright, not this. This was something else. X squared. Absolute. And the graphs on the back. That's regular G, so we got so is this, and finally, that's it.